Okay, let's take a look at another type of free fall problem that's a little different from the last one. Okay, this one says a ball is thrown upward at 17 meters per second. Now remember our last problem, we didn't have an initial velocity, so it was dropped from rest. This one's actually being given an oomph straight up at 17 meters per second, okay? And what I'm doing for the sake of making this easier to draw, this is being thrown straight up and it's coming straight back down, but I expanded it a little bit here so that we have room to draw and write things in. But really it's just going straight up and straight down. It's not moving this way and it's not moving this way. So we got our 17 meters per second that it's being thrown upward with. All right, now we're looking for some different things here. This says how long is it in the air and how high does it travel. We don't know how far up this is. In our last problem, we knew the height something was being dropped from. So this one is going to have to be approached in a slightly different way. When we have projectiles like this, something that goes up and then comes back down, we're going to start dividing it into different chunks. It helps us understand what some of these numbers are telling us rather than just hoping an equation gets us there. So what I'm going to do is I'm going to break this kind of in half and say, let's analyze the up situation, and then let's analyze the down situation, okay? And if you look at it this way, you actually have more information here than you think, okay? I know that it starts at 17 meters per second going up. If we just look at the upward portion of this, it starts at 17. That is my initial velocity. Okay? But when it gets to the top, how fast is it really going? Well, there's a split instant right there where it actually isn't moving at all. Just when it gets to the top of its path and before it starts back down, there's actually a point right there where it's got a final velocity of 0 right at the top of that curve, okay, right at the top of its flight path. And that's obviously meters per second. So I have both the initial and the final velocities. The other thing I have here, acceleration. Now let's think about this. On this particular part of the path, when it's going up, is it speeding up or is it slowing down? As it's traveling upward, it's actually slowing down. So it has a negative acceleration of negative 9.8 meters per second squared. Okay, and that's kind of a different way of looking at it. Some people like to look at it just in terms of which direction things are traveling, and there's lots of ways to do this correctly, but this is how I'm going to approach it. It's slowing down, so I'm going to make it a negative number. Okay. Now, let's see what we can do with this. We have 3 of those pieces of data, okay? And we just kind of have to see where we can go. Sometimes you really don't know how to answer a particular question, so you just got to jump in and start doing physics and go, what can I figure out with this? Even if it's not where I think I need to go, let's just get some more information calculated and determined. So if I've got these 3 things, I immediately look over here and go, hey, I could figure out time with this one. All I have to do is plug in the 3 things that I know. So let's do some easy physics. Final velocity is 0. We're doing this one right here. Initial velocity is 17. Acceleration is negative 9.8 because it's slowing down. And time, we don't know. So if I were to solve this, remember I would subtract 17 over to this side, so it becomes negative 17 equals negative 9.8. And if I divide by negative 9.8, you guys know that dividing a negative by a negative gives you a positive. So I actually get a positive amount of time that it takes to make that path. Okay, and in this case, that ends up being about 1.73 seconds. Okay, so time was 1.73 seconds. Now, let's think about what that really means. That's 1.73 seconds to get from here to the point where it had no velocity, which would be the top of the path. So it's not the entire time it's in the air, it's actually the half time. So I'm going to label this in here just to make it easier to keep track of. 1.73 seconds. Okay? Now, you guys know enough about parabolas to know that whatever happens on the front half, it's exactly proportional, it's exactly the same as what happens on the back half. Okay? It's something that is, you're not going to see it skewed one way or the other as long as we aren't elevated to a different height to start with. So if it takes 1.73 seconds to get to the top, it's going to be exactly a mirror image on the other side. It'll take 1.73 seconds to get to the bottom. So I can go ahead and put in that total time of, in this case, that's 3.46 seconds. Now this is the kind of stuff I want to see in your homework, because if you will learn to write things out and draw them on a diagram as you go, you make a lot fewer mistakes. Just grabbing a formula and plugging something in, sometimes it's right and sometimes you're not really calculating what you think you are. So what I want to show you here is what those equations can do for you, all right? If I were to look at different spots, okay? So let's say I want to analyze a particular place on the downward half of this. Let's say, so it gets to the top at 1.73 seconds. Well, what about at 2 seconds? At 2 seconds, it might be somewhere right in here. So I'm just going to put that there. How do we know what's going on at 2 seconds? Well, that's what, if we're consistent, that's what these equations are going to show us. They're going to show us what's happening at 2 seconds. So let me take this one, for example, we were working with. If I want to know the final velocity, or that velocity at a snapshot right when it's at 2 seconds, how fast is it going? I'm going to go through and just plug in the corresponding data. My initial velocity was still 17 meters per second. My acceleration was negative 9.8. Okay. And my time now, I'm taking a snapshot and going right at the instant of 2 seconds, what's happening? So I'm going to put 2 right there. Okay, now if I plug all that in, that's going to be 17 minus 19.6. This is going to give me a negative value. Okay? And that negative value is going to be negative 2.6 meters per second. Now let's think about this. Negative, what does that mean? Well, it means it's traveling down. It's past the top of the curve, and now it's traveling down. This 2.6 very fast, not compared to where it started, because this thing is going to drop to Earth and end up going 17 meters per second at the bottom, just like it did on the front side. But negative 2.6, that seems about right. Okay. What if we picked at 3 seconds? So somewhere right in here. We would expect that from here to here, it's going to speed up quite a bit. So if we did at 3 seconds, I take my final velocity equals 17 plus negative 9.8 times 3. I plug all that in, and that's going to give me a value of negative 12.4 meters per second. Okay. So from here it's going negative 2.6, down here it's going negative 12.4. Basically, anywhere along this path, if I have things labeled consistent, I can plug in a time, a little snapshot there, and tell me exactly how fast it's going. Okay. Now what we haven't got to is how high it actually travels. Well, I want you to look at this and say, where was it when it got to that top spot? It was on this curve, it's right at this point at 1.73 seconds. Okay. Or I can just basically look at these equations and I can kind of pick out which one do I think is going to help me the most. And sometimes you have more than one option, but which one's sort of more direct or user-friendly for me. Now, x we usually think about in terms of horizontal distances, but in this case, x is just a displacement. It's the direction that it's accelerating, so it can be up and down also. You could change all these with y's if that makes you feel more comfortable. So I'm going to take a look at this one right here. I'm going to try to find the height. That final distance or displacement, that final x value should tell me how high it goes. So I'm going to use that one. It's not the only way to do this, but it's the way I'm going to pick. Okay. So if I want to use that one, I'm going to take my final height. What height did it start from? Well, it started at the ground, so it started from a height of 0. What was its initial velocity? Oh, we do have that. That was 17. And then the time, keep in mind, which time are we talking about here? Is it the entire time? What snapshot is it? It's right here. It's at 1.73 seconds. And then I have 1/2. Okay, now on this part of the path right here, what is happening to its acceleration? It's negative, right? It's negative 9.8 because it's slowing down. So if I'm doing that part of the path, negative 9.8, oops. And then we have our time of 1.73. That's the spot we're looking for. Okay. And that's squared. So this is going to be just a simple calculation. I don't have to worry about the 0. Multiply those together, square that, and multiply all those together. Okay. And when I put all that stuff together, I basically get a value of 29.41 right here. And I get a value of negative 14.66 right here. When I put those together, I get a value of 14.74 meters. Okay, now this is estimated. That's my final position. That should be about the top of the curve. What you're going to notice is this has always got kind of a pattern to it. I'm going to leave it at that. That's a little bit of a rounded version because I rounded some of these values off as I went. But usually this answer ends up being about the same as that right there. You're going to see a proportional relationships show up here when you start doing a few problems. This is what I would like to see. So when I assign one of these problems in your homework, rather than just seeing an equation with some numbers and then an answer circled, I would like to see the setup, the drawing, all of the pieces of the puzzle. That way when this comes out to be something crazy and it doesn't seem to fit, and you go, wait a second, I got a negative height, this went down, not up, something's off. And you can kind of trace your way back, or I can help you and we'll find out where that's at. So just show everything. And if you aren't sure where to start, you grab the data that you can come up with, you pick an equation, and you start figuring things out. And pretty soon you kind of accidentally lead yourself into this. It just takes some getting used to.